everybody. Today we're going to see together how to use EC700. This is a software for the energy assessment of buildings and can be used for energy performance certificate, energy audit, and more. The software is mainly designed in Italian and in English, and if you already installed this software inside of your computer and it's in Italian, now we're going to see how to change the language in English. So you need to open il Clima Application Manager, go to Tools, Strumenti, then Language of Visualization, Lingua di Visualizzazione, and then you can change from Italian to English. As you can see here, the new language will be shown only after restarting the programs. So if EC700 is already opened, you need to shut it down and open it again. So let's click OK, go to My Software, and then click on EC700. Now you can see that the English language is already working. Let's start with a new file at first, and then we're going to see an example. When you open a new file, you will see mainly the interface of this software. So on the top part, these are the main tabs you can see. So File, Home, Tools, Support, and General Data. This list of tabs here is going to change while you go through your commands. So if we're going to be in the graphic input, new tabs will appear in order to be used in the specific section. On the left, as I was talking, you have the Commands tab, and there are a lot of buttons, and they are listed in a logical order, so from the main input data to the output one. At first, as you can see, apart from general data, all the other fields are not usable, are not available, because you need to set some main data to be used after, and if you don't set that, it's not possible to go forward. On the first part, you need to set the file data, and here the main information regarding the building, but one of the main important things is the building type. So here you need to define which type of building use is inside of your building, and let's say an office. Okay. Then here you need to define if the building is for public use, if it's an historical one, and then if you need to which type of document you need to perform. So low assessment, energy audit, or free model. And on the right part, additional calculations, so you can also perform dynamic hourly calculation, but also coding loads and so on. So let's say we're going to use a dynamic calculation. Then you need to set the climatic data, and in order to do that, you need to define the municipality. Let's say we are in Turin. Okay, if you do that, all the information are going to be set in an automatic way. You can also analyze the hourly data, and as you can see here, you can see all the information regarding this climatic data from an hourly point of view, but you can also look at the tabulated values. If you want to use not the typical meteorological year, you can also load different data that may be, I don't know, the real data of your settings. Then in a regulatory regime, you will be able to set different calculation options, such as the way you're going to analyze the thermal bridges, the surface resistance, and so on. Let's say we use the detailed calculation for sun space and uncommon room. As you can see here, since we set the building type and the climatic data, new tabs appeared to be used. In order to unlock also this one, you will need to define a building in the graphic input to define zones and rooms, and then all the other things are going to be able to be used. Now let's shift to an example file. Now we're going to see together how to perform a dynamic hourly calculation using an Italian and European standard UNI and ISO 52016. And as you can see on the left part in the commands, some of the buttons are not available, such as the low compliance check and the energy certificates. This is because in Italy, use of dynamic hourly calculation is not allowed to perform such task. We can now move to the building envelope elements. Here in this section, you will need to define all the stratigraphies and all the components that are available in your building. We can start with walls as an example. So if we consider a component, the first thing you will need to define is a name for the component and the type. It will define the boundary condition that are adjacent to your component. So in this case, we have a T type, so from condition to external environment. But of course, you will be able to consider all the possible combination of environment adjacent to your component. In the first tab, General Data, you will be able to define the main properties of the component. In this case, you can see a brief picture that represent the stratigraphy you will define in later tabs, and also a brief description of all the components that compose the element itself. Here, in known data, you will be able to use standard stratigraphies for your components. In this section, stratigraphy, you will be able to define all the components for your elements by selecting them from the archive and by just dragging them and dropping into the list of components. Of course, you will also be able to insert user-defined components by using the archive. After you did that, you can also analyze the thermohygrometric checks. You can see some graphs that represent the temperature, the vapor pressure, and the condensation and evaporation inside of your element. And in the end, you can see some general results regarding your component, such as the thermal transmittance, the thickness, and other relevant properties useful for the energy assessment. For what concerns floors and ceiling, the input required by the system are almost the same as for walls. The only thing that you need to keep in mind is that since the thermal flux is changing from floors to ceilings, because in one case is upward and in the other case is downward, you will need to define, in case you have a component between two rooms that you're considering, two different stratigraphies. You can also do that by using this section, import from ceilings or import from floors. Regarding the thermal bridges, you will be able to define all the thermal bridges that are available in your building. You can just create new thermal bridges and associate the thermal linear calculation transmittance here. You can also use mold simulator, which is mainly based on a finite element analysis. And the third way is to use EC709, which is this section here. Is another module, and it's based on an abacus of thermal bridges. So you will be able to select the main type of thermal bridge you're considering, the insulation position, and then by going forward, you will be able to calculate the actual thermal transmittance associated to your component. We have then the windows, so after the opaque components and thermal bridges, we also have, of course, transparent component. Here, again, we have a first tab with general data, where you can define the main properties of the window. Then you can also define the shape of the window and the dimensional properties, such as the dimension of the frame, the number of partition in your window, and so on. In module data, you can also add other components to your window, such as roller shutter box, under window walls, but also you can also associate the thermal bridge between the window and the wall. In the glasses tab, you can define the transparent component properties, so the number of glasses, the thickness of those glasses, and the transmittance of the glass. We can also define blinds and shields properties here in the shields and blinds tab, and in the end, in results, you have, as for the opaque components, the main properties associated to the windows. Now we can move to the shading command. So here, since in the general data we decided to use an automatic calculation of the shadings, all the information regarding the shading that are related to the external obstruction, such as different buildings, trees, but also the information regarding the shading created by balconies, roofs, and things like that, are calculated in an automatic way after the definition of the relevant information in the graphic input. So because of that, in the shading section, you will only find the information regarding the blinds and the curtains. And here you will be able to define profiles of use for these things. Now we can see the graphic input. Here you will be able to create a 3D model of your building using all the information we defined before in the building envelope elements. At first, here in the management section, you can define the different level of your building, so the different floor, and you can create and delete existing levels. On the upper part, you can see here a background section. If you click here, you will see CAD or picture, and you will be able to define and import a background in order to easier your building creation. Then you can set the north. Here in the thermal building elements, you can select all the components you define in the building envelope elements, and you can draw them directly in the model. After this section, you will be able to define and insert inside of the model the condition spaces and the unconditioned spaces and so on. You will need to define all the information for the different thermal zone in your building, so you can create new thermal zone, and you will need to define the general information regarding this zone, such as some zone data, the lighting information, and some relevant data for the hourly calculation, such as the temperature set point, the humidity set point, the internal gains. For the internal gains, you will be helped by some data taken from relevant standards. So if you don't know this data, you can use them. And in the bottom part, you will need to define the hourly profile for your building. So define the temperature and so on. In the room data, you will assign a thermal zone related to the specific room you're analyzing. You will need to define some general data regarding the room, again, lighting, some hourly calculation information, such as the curtains, the blinds, and by default, the zone hourly profile will be used, but you can also change that and use different data depending on the specific room you're analyzing. After that, in the graphic input section, you will need to export all the information you already defined here in order to be used in a different section. Other relevant buttons you can use in order to help you in analyzing if what you did was correct or not are the 3D section, and here you will be able to see the building you created in a 3D way, but also the rendering section where you can analyze a render of your building and you can see the solar path and so on. After that, after you exported all the information on your building, we can go in the following commands. Here in the subspaces and air condition room, if you define an analytic definition of the air condition space, you can define all the information for the air condition rooms you have. In the zone condition room section, you will be able to see all the zones and rooms you defined in the graphic input. So here, in this section here, zones and rooms, if you select a specific zone, you will be able to see all the data defined in the graphic input, so zone data, all the dimensional properties, heat capacity, and heating load data, lighting, and the hourly calculation information defined in the previous section. You will also be able to see all the information regarding all the rooms you defined before. So if you select a specific room, you will be able to see the room data. So again, the dimensional properties, the temperatures, the ventilation information, and so on. Here in the heat loss elements, you will be able to see all the components that are linked to the specific room you're analyzing. So in this case, you will see the code of the specific component, and in the bottom part, you will be able to see a brief resume of all the components that are available in your building. Again, you will be able to see also the data regarding the lighting and the hourly calculation information for the specific room you're analyzing. Then, after the zone condition rooms, we can move to the systems. In this section, you will be able to define all the relevant energy services for your building. So you will be able to select heating, ventilation, domestic hot water, and so on. And for these services, you will be able to define if the generation is centralized, autonomous, and if there is combined or separated generation. After you performed all the needed changes, you will apply those changes in order to allow the system to create or update the system configuration tool. Here in the visualization tree, we will be able to see all the systems defined before with the representative icons. So here we can select the centralized heating domestic hot water system. We will see some general data regarding this system. We will be able to analyze and define the subsystems, such as the emission, the control one, and insert some user distribution information. Here, you can define other information regarding the water inside of these systems. And in the upper part, you will be able to analyze also the storage subsystem and also the generation one. In this case, we have an hybrid system with an heat pump and a condensing boiler. And here in the generator section, we will be able to define all the information regarding the first generator, in this case the heat pump, define all the properties, all the declared performance, and all the information regarding the circuit. And of course, we will be able also to do the same thing for all the generators. Then we can move to the next section. Here in the building results, you will be able to analyze and to perform the energy need assessment for the building. At first, you will be able to define which zone you're analyzing, and by clicking this button, Calculate, you will be able to perform the hourly energy assessment for the selected zone or for all the zones. In calculation options, you will be able to select and define some general calculation option according to an ISO 52016 Part 1. Here, you will be able to define which type of calculation you're going to perform. So using the actual system you defined before, using a system with unlimited power, or without the system, so performing a free-floating assessment. You can also change the season in which you are performing the analysis, so the real one, a customized or conventional one, for both the heating and cooling season. In the bottom part, you will be able to see the results of the energy need assessment, analyzing the whole year or custom periods through a graphic analysis, but also through a tabular analysis of the results. Of course, you will also be able to export these results in case you need to perform further analysis. You will be able to use these general results, but also more detailed one and aggregated results. In this case, we can see the power, but other tabs are available, such as the one analyzing the operative temperature. In this case, we can see month by month the minimum and maximum internal operative temperature, but you will also be able to analyze other aggregated results, such as the operation hours compared to the load factor of the systems. In the other tabs, apart from the hourly calculation one, you will be able to see the heating load results, but also heating and cooling energy analyzed in a monthly way. In the primary energy results, you will be able to analyze the primary energy results for all the services available in your building. Here, if we analyze the heating section, we will be able to see the thermal needs related to our building regarding the heating service, the overall result in terms of primary energy, and all the efficiencies related to the various systems and subsystems. In the following tab, here, load distribution, we will be able to see the load distribution between the various generator inside of our building. So in the red, we have the heat pump, and in the brown part, the condensing boiler. Then we have another tab regarding the mean temperature for heating in this case, and we will be able to see the water temperature related to the external temperature for our system. The last tab is the energy signature one, and we will be able to see the results in terms of average power related to the monthly temperatures of our locality. All the systems have similar results, all the services. We can go to the last one, the total, so we can see the primary energy needs and performance index for all the services in terms of primary, non-renewable, renewable, and total energy. Also the energy carrier and CO2 emission, and also graph that analyze in the same way, but from a graphical point of view, results in terms of energy need for primary energy and CO2 emission. These are just some of the things that you can perform with the EC700. We will not see other things today, but you can also analyze building automation and control systems, improving actions for refurbishment of your building, and as we saw before, by changing from hourly calculation method to monthly one. You will also be able to perform low compliance checks, energy certificates, and more.